Hello everyone, this is Nikos Kapsoulis and this is the Infinitech Know Your Customer and Know Your Business on-chain data governance. This is an explanatory video how things work and what is the underlying infrastructure that is available and what we do actually with the smart contracts on the chain. In order to introduce a bit the concept of the KYC and KYB, we're talking about the well-known finance field mechanisms that are used in order for the governments and the central banks and so on, for all the financial institutions to be able to understand the verification of an identity when the client onboards on their and uses their services and they have business relationship with them. In this context, the KYC, KYB, of course, it belongs in the wider area of the anti-money laundering and the due diligence that it is performed globally in this kind of sense. But why we focus here on the decentralization and the immutability of the blockchain is because the centralized systems have these faults and vulnerabilities that can be addressed through a permission blockchain, as we will see. To kickstart, one of the main benefits of this solution is the rapid client onboarding, in the sense that a client will start and will onboard on a system which is a blockchain system, and when the client wants to have a different business relationship with another financial organization, they don't have to onboard again. They just give their consent in order to share the information through the blockchain. And of course, the client data updates perform more conveniently in the sense that it's not necessary to update all the records in different locations in different partners and organizations, since they are all stored on the chain and it is tracked on the ledger. Let's go a bit on the architecture of the schema here and how we approach this kind of use case. On one hand, we have the Infinitech blockchain network, which is a permission blockchain network based on the Hyperledger fabric, of course, and how the users try to interact is through the smart contracts, of course. And the kind of users that we have actually is the clients and the financial parties. Financial parties enable verification of the client identity, and what else happens in this workflow is that between financial parties there is the request to share some data of clients. So in our solution, what it is done actually is that this sharing mechanisms happens through information groups, which is private ledger inside the ledger, this kind of concept, and the data is securely shared between financial parties. Of course, the client's consent is required from the beginning, and this is what happens here. Let's go to the solution and the smart contracts. And the smart contract explanations actually. How we approach here is that every client party that engages in the system, they provide their KYC and KYB information, and through smart contract functionalities, this information is stored on the ledger and managed. The deployment of the smart contracts in the Hyperledger Fabric blockchain use the form of chain codes, if it is which is a very well known name in the space of Hyperledger Fabric. So, in order to get more deep in this explanatory video, here we have the package of the chain code, and the thing is, first of all, that we develop in Golang, and what we are going to see in the next step here is actually how the chain code is formed in Golang, how it is called, and how it all puts in together in one code of smart contract logic and the business intelligence behind it. To begin with, the chain code, of course, we have the import of the specific libraries and the important contract API that helps to implement functions, smart contract function actually. In our case, we define the party, which is the user client that submits their KYC, KYB data, and each of the fields represents the specific data per se. And of course, the smart contract structure that brings this API and helps implement inside the chain code. And from this start, we go specifically now to the dedicated functions that are developed and they are managing the party struct through the smart contract API. First of all, we go to the create party. Of course, that it uses another function, as we will mention, the party exists, and what it does, as said from its name also, is of course that it creates a new record on the chain about KYC and KYB data of a client. A small note here, as we mentioned also in the documentation, is that it is very good practice to have, especially in Golang and in the blockchain development, to have checking every time that we want to take an action or something on the ledger. So this kind of check has to do with the existence of something in order not to query empty things on the chain. And this is the party exists function, and it comes also with the create party. Last but not least, here we are using the Marshall functions for the JSON, Marshall and unmarshall, and this is of course the JSON encoding and how we shift between the encoding and the data in order to handle the function and submit it on the ledger or retrieve it from the ledger. The logic, of course, is straightforward, and a party struct, as we saw before, is created, and after it's encoded, it's stored on the ledger. Through this transaction. Of course, the usage of the contract API is, and the dedicated interface is constantly being used in these two functions, and we can go to the next one, which is in similar logic as we will see, since now, as you understand, we're seeing the CRUD operations, and so we go to the read party, where we of course check again on this good blockchain practice if there is something on the ledger, and then we read it actually from the ledger, and we have the encoding of the unmarshal at this time. In the same manner, when we want, we have already something, a KYC, KYB data of a client on the ledger, and we want to update it. We have a new document type and a new legal number, for example, for this document, or we have a new validity period because the previous one expired, and the client wants to renew their KYC validation actually in our system. we have here we have the update party and how this information stores actually on the stores a new record with a new information on the ledger, the updated one for the specific client. I'm going to the next function, which is the delete party, and what we understand here about the right to be forgotten actually is that as soon as this function is called on a client's data, the financial parties that are participating and they are handling this kind of data, they have no longer access to the party's data, and the client's data is not visible from them. Last function on this kind of code would be the getAll, which retrieves through a range query all the data that we have in the specific state of the ledger. And in order to understand how all these functions are called, we have a main function, of course, similarly to other code structures. And what happens here is that in this main function, what we have is that we define the libraries again, but we define, of course, the chain code, and we call it, and we initialize, we create it actually, and then we call it in order to start. If everything goes well at this point, then the smart contract is there on the other ledger and running. Now we can move on to the information groups, and as we mentioned before, the information groups are actually what we call that this concept that we have a private ledger inside the blockchain network of fintech, and this is in order to understand this better, the thing is that a financial party can manage an information group, and what we do here in this application is that this financial party grants access or forbids access to the information group that is a specific KYC, KYB data of clients. So in this grouping of the data, every financial party that has a managing role on this kind of group, they are able to grant and forbid access to other financial parties about the client's data. And connecting what we said in the beginning, actually, this is how we can share information between financial parties, of course, and how we don't have to update it, or the client doesn't have to onboard on the same party, on a different party every time, because the information is stored on the same ledger. So in this information groups concept, we have also the practical functions that they execute, and they are signed transactions and approved transactions on the ledger actually, and they modify this kind of visibility that we just described. First of all, we fetch the channel configuration, and by we mean the financial party fetches the channel configuration for the most recent configuration block actually. For the specific information group which we have represented as the Hyperledger channel, the data is retrieved. So in order to grant access, the create config update is used, and a new transaction is prepared in order to add or remove access from a financial party to another one. And as soon as this is completed as well, the whole transaction has to be signed, of course, by the administrator with the signed config transaction as peer organization, which actually signs the configuration update transaction and is the financial party administrator. And this means that the whole process of retrieving the last block, creating the new update, which is adding the financial party to the information group, which is here the Hyperledger channel, or removing, as we will see, forbidden access to this information group, and then signing the transaction by the financial party administrator of the network and the information group. So in similar manner, the forbidding access occurs, of course. Now we will move on to the application and have all this put together in a user-friendly logic, actually. And what happens step by step is that first in this figure we see that this client has just submitted their KYC or KYB data. It depends if the client is the individual or a company, of course. Know your customer and know your business. They have just submitted their data on the chain. On the next figure, in figure 4, we see that a specific financial party has grouped the KYC KYB data under the specific information group, and they retain their data on the chain. When another in the next figure, when another financial party wants to have access in this specific group of group 1, actually, in the application screen, actually, of the first party, there is this permissions functionality, and the financial party can grant access to the requester. As soon as this is completed, what happens is that the financial party can now access the data, and as we see, for example, this financial party has now access to the group 1 data, and of course they have the group 2 as it is their own managing group. So in a similar sense, the second party can grant access or forbid access to the first party for their managing information group, which is group 2 in the last example. And last but not least, we have, of course, the forbidden access, just to see it also from the permissions functionality point of view. And in the first example here, when this happens is that the second financial party forbids access to the assigned group for the financial party, for the first financial party. The entire project, of course, can be found in the Infinitica Marketplace, and thank you for watching.